Math 1343, Week 3, Video 4, Estimating the Difference in Two Population Means. This is actually not that difficult. It's really pretty easy. Like the previous confidence intervals we've seen so far, it requires the same 4 steps. You have to make adjustments when necessary. Now keep in mind that if you have 2 populations, then you will have 2 samples, and therefore you will have 2 sample sizes, 2 sample means, and 2 sample standard deviations. So every time we deal with any of those, we have to accommodate for both of the populations and both of the samples. And it starts right away, the first step, which is to find t. Why does estimating 2 population means affect this? Because when we find t, we need degrees of freedom. And for degrees of freedom, previously it was just the sample size minus 1. Now what I'm about to write is incorrect. Well, it's not complete. I'll show you what I mean in a minute, but hold off writing it down. But if we have 2 populations, then we have 2 samples, and there's no guarantee their sample sizes are the same. So how do we know which sample size to use? The answer is the degrees of freedom is the minimum of the first sample size minus 1 and second sample size minus 1. So another way to think of it is you take the sample size for each, you take the degrees of freedom for each sample and just use the lesser of the 2, the minimum of the 2. So small adjustment there, but it's an easy one to accommodate. Now by contrast, the second step, finding the standard error, does require a lot more modification because, and again, I'm going to write the previous formula, don't write it down yet. The previous formula was this. So what's the new formula? Because we have 2 samples and therefore 2 sample standard deviations and 2 sample sizes. Well, it's a little tricky to justify algebraically, but the formula is essentially the sum. Let me rephrase this. The formula for this standard error is the square root of the sum of the squares of the standard errors of the individual formulas. In other words, the first one has a standard error, we would square that. The second one has a standard error, we would square that. It's the same formula there. But I'm not going to expect you to do that. I'm just going to put what's supposed to be inside of there. So if we took the formula for the first standard error and squared it, the s on top would get squared. But on the bottom, the sample size was the square root of n1, but squaring that would kill the square root. And we would get the same thing for the second sample. You don't have to remember that the standard error here is the square root of the sum of the squares of the standard errors of the individual samples. You just have to use this formula. I was just explaining where it came from. Third step really doesn't change. In any confidence interval, the third step is to find the margin of error, which will be the product of the first 2 steps. But the fourth step will change. And the reason the fourth step changes, and again, I'm about to write the previous confidence intervals move here, so don't write it down yet. The previous step was to take the sample mean, the point estimate for the population value we were estimating, and stick a margin of error on it. But this is not the sample version of what we're estimating. What we are estimating is the difference in 2 population means. I'm going to go back up to the title for a second and write what that looks like. The difference in 2 population means is mu1 minus mu2. This is what we're estimating. So when we build our confidence interval, we center it around the sample version of that, and the sample version of mu1 minus mu2, x bar 1 minus x bar 2. Vector. Plus or minus the margin of error. So ideally it's the same 4 steps. We just have to make accommodations for the fact that we're messing with 2 populations and therefore 2 samples instead of 1 of each. Finding of t, we find the degrees of freedom for each sample but use the lesser of the 2. In the second step, we have to adjust the standard error formula to compensate for 2 standard errors. In step 3, we have to, well, we don't have to make any adjustments there. And in step 4, we have to adjust the point estimate that's going to be the center of our confidence interval. All right, in the next video, we'll do an example.